Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's illustrate the limit of a rational function using a table of values. Take note that a rational function is a function where a variable can be found in a denominator of an expression. We are going to look at the correct processes in determining the limit of the said function, but here using a table of values. Let's start by identifying a certain rational function. Let's say f of x is equal to x squared minus x minus 2 all over x plus 1. We see here that there is a variable x that can be found in the denominator of this expression, hence this is called as a rational function. And let's say that we are going to solve for the limit of this given function. You can rewrite this without parentheses because this stands for a certain monomial, or if you would like to, you can even enclose it in parentheses, but for the time being, let's stick with this expression. As x approaches, let's say, negative 1. Let's find out the limit of this given function, or the value of this entire expression, by the use of table of values. So we are going to use here two values as we pick values from the left of negative 1 going towards it, but will never touch negative 1. And we're also going to use values from the right of negative 1 going towards the value of negative 1. Let's start with the values from the left. Let's say x here. This will be our table of values, and f of x. Let's pick here an integer. Let's say it's negative 2. Okay? If we are going to have negative 2 here, we simply need to substitute that on our given function there and to solve for the value, and then later on we see a trend. We have the square of negative 2 is positive 4 minus x, which is negative 2, so minus negative 2, that's plus 2, so 4 plus 2, that's 6, minus 2, that's actually 4. By the way, you can use calculators here if you would like to, but what happens here, our numerator is positive 4, but our denominator is negative 2 plus 1, negative 1. We'll have here negative 4. Again, you may use calculators if you would like to. Next, let's have here negative 1.5. So let's get closer to negative 1. So the square of negative 1.5 is equal to 2.25. Okay, 2.25 minus negative 1.5, so simply plus 1.5, you will have 3.75 minus 2, you will have 1.75 only for our numerator. But our denominator will have negative 1.5 plus 1, so that's negative 0.5. So if you're going to divide the result earlier, 1.75 divided by negative 0.5, you will have your result of negative 3.5. Again, you may use calculators to see the actual results. Now let's get closer. Let's have negative 1.1. So when we use that, the square of negative 1.1 is positive 1.21. Okay? And then minus negative 1.1 would be plus 1.1, so that's 2.31. And minus 2, you will have 0.31. That's only for our numerator. Our denominator would be negative 1.1 plus 1, that's 0.1, or negative 0.1. So earlier, 0.31 divided by 0.1, you will have a result here of negative 3.1. Okay, let's have another value for our x. Okay, let's get closer to negative 1. So you have negative 1.01. Okay, so same process. 1.01 negative 1.01 times negative 1.01 is equal to 1.0201. By using calculators, please use it. And then plus, because that's minus negative, so plus 1.01, you have 2.0301 minus 2, so you have 0.0301. That's only for our numerator. In our denominator, negative 1.01 plus 1, so you have negative 0.01. So the result earlier, divide by that, you will have here negative 3.01. To finish this, let's have one more, negative 1.0001. Okay, so we're getting closer to our value here, which is negative 1. So let's try the square of that. Okay, you will have to use your calculators here, and then we subtract. The result will be subtracted with with that value, so it will be plus 1.0001. okay, then minus 2. That's for the numerator only. Take note, our denominator we also have the same value of x, so we have negative 0.0001. So we will be dividing that with all of the results. You will have negative 3.0001. Probably at this time you can see that as we try values of x from the left, negative 1, going towards it, we see a trend for the value of f of x, and that's actually going towards negative 3. Let's find out if it's the same case if we are going to pick values from the right of negative 1. The limit will only exist if the value or the limit from the left and from the right have the same results. So let's try values after or the right of negative 1. Let's have, of course, you could try 0 here. Okay, so if we're going to try 0, 0 squared is 0 minus 0, so you have negative 2 in our numerator. Our denominator is 0 plus 1, so positive 1. You will have here negative 2. Okay, it's easy to use 0, right? If you could use 0, then use 0 because it's easier for us to have that. Next is going closer to negative 1, so let's have negative 0.5. Okay, we'll be getting closer to our negative 1. So we have 0, you're going to square that first. So 0.5 times 0.5, that's, negative 0.5 times negative 0.5 would be positive 25. Okay, and take note that we have also minus negative still. So you will have here plus 0.5. You have 0.75, but you will have to subtract it with 2. So you have negative 1.25 for your numerator alone. Our denominator, we have negative 0.5 plus 1, that's 0.5. So we have negative 1.25 earlier, divide by 0.5, you will have here negative 2.5. Next, we have negative 0.9, because we're getting closer to negative 1. So let's have 0.9 or negative 0.9 times negative 0.9, that's positive 0.81, and then minus 0.9 or negative 0.9, so plus 0.9, you will have 1.71, that's negative, positive 1.71, but then you will have minus 2, so you have negative 0.29 for our numerator. Take note of that, negative 0.29. For our denominator, you will have 0.1 as a result if you're going to use negative 0.9 on the value of x. So you have negative 0.29 divided by 0.1, you will have negative 2.9. Okay, next we'll have negative 0.99. The same process, you square that, then minus that, because that's minus x here on our function, so it will always depend on our function, so that'd be plus 0.99. okay, and you subtract with 2. Take note of that for your numerator, and then for our denominator, that's negative positive 0.01. So if we're going to divide earlier with the result, you will have negative 2.99. Let's have one more. So negative 0.9999. So we're getting closer to negative 1 here. So you just simply need to plug in that on our equation. You do it step by step. And again, you may use your calculators there. You square it first and minus that, it becomes plus 0.9999, and then you subtract by 2. Whatever will be the result of that, you then divide with the result in the denominator, which is actually positive 0.0001, which will give us negative 2.999 and 9. As you can see, as we get closer to negative 1 with all the values from the right of negative 1, the trend for our f of x is also going to negative 3. Since the values of f of x as we go to negative 1 from the left and from the right are the same, we can say and go back to this notation here, the limit of the function x squared minus x minus 2 all over x plus 1, which is a rational function, as x approaches negative 1, is equal to the same value of negative 3. So this is how we illustrate the limit of a rational function using a table of values. So what are you waiting for? Subscribe now!